Monday is a school day, so we will be finishing off 8-3. You then get Thanksgiving, and then we have 1 week, essentially. And in that last week, oh, 2 more people have arrived. In that last week, we will be doing chapter 9. And that's it. Everything's done. The following week after that, which I believe is December the 7th, is a school day. Right, it's a class day. And what will happen on that, oh, excuse me, the damn thing's going weird on me. Something's weird's happening over here. Let me get this fixed, or I'll just distract the heck out of me. I've got 3 people or 2 people in the waiting room. Why can't they come in? Okay, while they're coming in, I'll try and remember what I'm saying. So, this coming Monday, finish 8-3. The rest of the time is Thanksgiving holidays. The following week, chapter 9. The following week, Monday is a school day. We'll be using that to revise for the final. So that will be, you'll be given credit for attending it or not. You'll just get credit for that day as an attendance or participation, because it's going to be revised for your final, right? And then what's going to happen is, I can't remember because I've got so many classes, but I'll look it up maybe for the next time. Unless somebody in the top of their head, what day is our final?
The 11th.
The 11th, okay. So whatever day the 11th is, let's see, 7, 8, 9, 10. Friday. Friday the 11th, okay. So Friday the 11th of December is going to be your final, and that's it. We're done. Homework is due on Sunday the 6th, and that is up to and including chapter 9. And we should have all that done. I want to try and clear the slate so that the week that you've got for the final, the only thing you should be focusing on is the final, right? Getting practice and looking over stuff and whatever. Looks like Theo List is again, or this thing's playing things on us. Theo, did you get kicked out? Because it looks like you're coming back in again. Theo, can you even hear me?
Yeah, I can now. It just keeps like closing out Zoom.
Don't know what's up. It's just been awkward as it can be. Yeah. Okay, let's talk about chapter 8.3. We are basically, there are going to be 2 things in 8.3. Wrong number. We are going to be looking at 8.5. There are 2 things in 8.5. What we are going to do today, not pen anymore, is hypothesis test. With the difference in 2 proportions. And on Monday, we'll do hypothesis test, but the difference in 2 means. Let's show you how this thing works. It's an extension of what you've already done, right? You know how you can tell a hypothesis test with means and a hypothesis test with proportions. Most of it, except this first question, is going to be done using SALT. So it's going to be pretty quick for the number crunching part. So we're going to have a story here, and basically you're going to have 2 populations. You call population 1, and we're going to have population 2. And we are going to ask a question comparing the 2 populations. And the questions end up being one of 3 types. So I want you to imagine that we ask a question. What should we ask? Oh, let's this one be males, and we'll let this one be females. And I'm going to ask you a lot, because there's a big enough class, we should be able to do this. I think there's about 35 of you. Okay, here it goes. Right, only those who want to take part. So that means I'm going to have to count the yeses and nos probably to be accurate. Right, we'll start with the guys, and so I need to ask a question that might be different. I can't think of anything. That's a sponge. I'm trying to think of some question that would have a yes or no that the males and females won't mind answering, so it can't be personal.
Let's see. That's like, do you like eggnog?
That's a good enough question as any, right? Okay, guys, do you like eggnog? Hit your little thumbs up thing and I'll count you. 1, 2, 3.
Like certain
This
types
is-
of eggnogs and
Oh, we're not getting
like,
detailed
okay.
here. Nah, any
Alright.
brand of eggnog, including or not including alcohol.
So it's binary. Okay.
Right, so now the fact is that you just went up and disappeared too quick. So same question, go for it again. Do you like eggnog, guys? 1, 2, 3, 4, 5, 6, 7, 8. I make it 8. Okay. So let's wind that back. Now, how many of you do not like eggnog? And that's me for sure. 2 of us. Okay, it is what it is. So in our sample of 10 people, the proportion who liked eggnog was 8 out of 10, or 80%. Oh, what am I testing for? Here's what I'm testing for. Is there enough evidence to prove that there is a difference between the sexes on liking eggnog? Well, right now, 80% of the guys like eggnog. I don't really care if it's 40% of the girls like eggnog or 95% of the girls like eggnog. I just hope to God that it's not that number. Otherwise, this example is going to crash and burn really quickly. So any kind of eggnog, girls, stay your little thumb up if you like eggnog. 1, 2, 3, 4, 5, 6. Okay, I got 6. Okay. Now, wind back. If you don't like eggnog, 1, 2, 3, 4. Oh, thank you for being different. Good. I make that 8. So it was 8 and 6, wasn't it? So 6 and 8 was 14. There we go. So the 14 who answered, at least 14 I managed to count. 6 of you like eggnog. Over here it's quite different. On my calculator then, we have got 6 divided by 14, which is about 43%, very roughly. So this is a hypothesis test that is set up to compare the difference between two groups, right? So in this particular storyline, let me go back to sharing. Oh, we are sharing, okay. This is the data that I have. You could just say, look, 80% of the guys like it, only 43% of the girls like it. Hey, clearly different. Well, we're not really allowed to say that that is evidence because the samples are tiny. And so what do we get to do then is that we get to do a formal hypothesis test. So let me take you through this. This is the only time I'm going to do this question by hand. And I want to do it once by hand so that when we do salt, at least you can say, okay, I know how I do it by hand, but I'm glad salt does all the number crunching for me because it takes forever to do it. Well, we'll start off with step one. Oh, I almost forgot. What kind of significance level should we have in this question? Because that's part of the question. You're always told it. Do you want a 1, a 5, or a 10?
5.
Okay, so a 5% it is. Go back to step one. I need a null and I need an alternate. Well, I'm trying to prove that there's evidence that they're different from each other. So the way of saying that is that the proportion of guys who like it is not the same as the proportion of girls who like it. Does that make sense for the null hypothesis? Written this way, what do you think the null hypothesis is going to look like if this is what the alternate looks like?
That the guys and the girls will be equal.
Correct. Isn't that very similar to what you normally do? Like mu is equal to 40, mu is not equal to 40. Isn't that the usual pattern? The null hypothesis always has the same thing going on, but with an equals. In this case, this is not equal to, right? So here's our first little idiosyncrasy. This is fine, nothing wrong with it. But there is an alternate way that this, oh, it's a bad choice of word. There is a different way in which this is written. And as far as salt's concerned, do you know mathematically these are the same thing? You agree? That if P1 is equal to P2, doesn't that mean that P1 take away P2 is 0? And if P1 is not equal to P2, do you see that it's that? So this is how the textbook and this is how SALT is going to write down these. I prefer this because to me it's easier to understand what's been told, but this is true. Can anyone tell me, is this a one-tailed test or a two-tailed test?
Two-tailed test.
And the clue here is the not equals to, isn't it? So that is our hypothesis. Let me show you the other two situations, totally different stories, just randomly picked off the top of my head. You could get P1 is bigger than P2. So that's guys more than girls, perhaps, in a different story. You could also get that it's less. Now, do those two and that one look very similar to what you do? The mean is bigger than 10, the mean is less than 10, the mean isn't equal to 10. Right? It's exactly the same. And they even have the same names. This fella here is called a right-tailed test. This fella here is called a left-tailed test. And that's the only hypothesis tests in the universe. You're either different, right, not equal, or you're bigger, or you're less. Now, I only gave these versions, but do you know you can convert that into P1 take away P2 is 0, and P1 take away P2 is greater than 0. So let's, step one done. Step two is we're going to find Z-score and the p-value. And in salt, you will be told these two guys, but we're going to calculate them from scratch so you can see what it looks like. To get the z-score, you take p1 hat, take away p2 hat, and you divide it by p1 hat 1 minus p2 hat over n1 plus p2 hat 1 minus p2 hat over n2. Do you see why you will probably never want to do any of these questions by hand? Right?
Professor,
Yes.
in a final, when you expect us to show our work, we don't have to go through the whole equation, do we, if we have a salt
No,
thing?
no. If you were doing this question in a final, I would expect you to use salt. What I'd
Okay.
expect you to do is to try and write down the numbers that you're going to use for salt.
Okay,
know,
because I was like,
so
I want to know if I have to put that down, basically.
No, you do not have to put that down. The test would last twice as long if you had to write these darn things down. So when you get a question and there's a salt button there, you can basically let the salt do all the number crunching for you. Just try and write down the null and the null and alternate hypothesis and the numbers that you would use. At least then I can check. Well, actually, if you do that right, the question's going to be right. And if you do it wrong, at least I can see what numbers you thought you were going to use, and therefore I can still give you partial credit if you do it correct, but with the wrong numbers. Let's just pretend that for some reason you thought this was 0.2 and this was 0.5, right? You'd be able to do the question, right? The answer would be wrong, but at least I could figure it out what you were doing wrong. So it's not like you don't write everything down, which is true. You don't write everything down, let's phrase that. But it is a good idea to at least write this part down, right? Right, and the one and only time you're going to see this, 0.8, take away 0.43, all over what is probably the ugliest square root in the world, 0.8, 0.2 divided by 10 plus p up to 0.43, take that away from 1 and you get 0.57 divided by 14. And that is definitely going to be done on my calculator. So a bracket 0.8, take away 0.43, close the brackets, enter. That's just too much for my brain to take, so I'm going to do it separately because that square root is massively ugly. So here we go. Square root 0.8 times 0.2 divided by 10, add this guy now, 0.43 times 0.57 divided by 14, and I get the answer nothing 0.183. And now I can just do 0.37 divided by 0.183, and the answer I get is roughly 2.02.
Question.
Yes.
In the formula, under the square root, the P1 hat and then 1 minus P2, is that supposed to be P1?
Yes.
Okay, thank you.
Thankfully, I did use P1 here, so the number is correct. Right, that is one ugly calculation, right? So you don't want to do 20 questions where you have to do that, and you won't need to. Continuing with that, let's get the p-value. The p-value is the probability that you get a z-score. Since this number is positive, won't it be a z-score greater than that? And writing it down, this is a two-tailed test. That's going to be important in a few seconds. On our calculator, we go, oh, I know what I can do. That's a footery little calculator. Let's show you a big calculator. You might be able to see the buttons I'm pressing a lot clearer, especially if you go back and look at this video. Right, so to get the p-value, I'm just saying this out loud, but I'm writing it and you can see it when we return. It's going to be the normal CDF. Because this is a number 2.02 and we want it to be bigger than 2.02, we go second distribution. And it's option 2. We hit enter. And normal CDF, it's the number, comma 9, comma 0, comma 1. Right? When you want bigger than something, it's the number, comma 9. When you want less than something, it's -9, comma the number, right? There's two flavors of that. And the answer that I got to that particular one, that 0.021 thing, that is the p-value. I guess if I round it off, it's 0.22. And that's step 2 done. Got the z-score. By sheer coincidence, these numbers are similar looking, but they shouldn't normally be. But I said, this fella, when it is a two-tailed test, what do you do to the p-value? You should know this, Holly.
Double it.
Yeah, double it. And so the p-value is not that guy directly. And you might say, well, why do you need to double it when it's a two-tailed and you don't double it for any other situation? It's to do with the visual thing. We've basically only found that, but because it's a two-tailed test, we have to account that it could have been on the other side. And so that the p-value, to compensate for the fact that it could have been on the other side, gets doubled. So that's the argument why we do it. Right, last step now is the test. So we do, is the p-value less than the significance level? In this case is 0.044, less than, I believe we decided on 5%, didn't we? Which is that one. And there's only two answers to this, yes or no. Would you agree in this case it's a yes? Right? So we have yes. And when you get a yes, there are a couple of sentences that are pretty standard. I'm just looking for them right now so I can tell you what they look like. You'll have 4 choices, but the one you pick when it's a yes will say something like this. At the alpha equals 0.05 level, we reject, I'm saying H naught, but it will say we reject the null hypothesis. And, I guess I'll have to go on the next line now, conclude that the data are statistically So if you ever say yes, you will always pick the sentence that reads like this. At the 0.05 level, whatever level it happens to be we did, we reject the null hypothesis and conclude that the data are statistically significant. That is the lawyer-esque way of saying it. They always have after this question, and what does it mean in English? And there's going to be two choices typically. And the two choices are, yes, it's statistically significant, or no, it's not. I'm trying to find a phrasing, at least if I can get an example where they did that. Okay, I take it back. There are 4 choices, but only one of them is still correct. Why can't I find things when I want them to be? And the one you're going to pick says, we fail to reject H not, well, actually, we fail to reject, let's call it its full title, the null hypothesis. That part's not that interesting. It's the bit after that that is. There is insufficient evidence. So if you can get a nice low p-value, you're going to say, yep, we've proved what you wanted. If the p-value is kind of big, you're going to say, it's not statistically significant. And that isn't the same as, oh, it means that the null is correct. It just means we don't know. Right, that was a pretty big, long, how to do it by hand. And that's the only time you're going to see it by hand. So you're probably kind of glad at that. So I'm going to switch over now and show you what the homework questions look like and how we use SALT to do pretty much half of what we did today. So hold on a second, I'm trying to find a question we can work with. Here we go. Okay, let's pick that one. Are you lot looking at question 6? Is that what you see? Good. Right, let me see if I can make it a little bit bigger. There. Okay, generally speaking, would you say that most people can be trusted? Okay. A random sample of 252 people in Chicago aged 18 to 25 showed that R1, that's equal 44, said yes. R1 is just a report, the people who said yes. So R1, 44 said it. Another random sample of 35 to 45-year-olds, 73 went and said that. Does this indicate that the population of proportion, people who can be trusted, is higher or for the older group? Okay, I didn't say that very clearly. When you look at this data, they're saying, is there evidence to show that older people, that's the 35 to 45-year-old group, is higher than it is for the younger group? So I'm going to have to write some numbers down here to keep track of them all. So I'm calling the first group the young guys. And the young guys have an N1 of 252 and a P hat of 44 over 271. Okay, if you do 44 divided by 271, just so I can get an idea, it's about 16%. And the second group is the older group. And in that group, there are 271. And the number of people who said yes was 73. And so 73 divided by 271 is about 27%. So just on the raw data, older people think you can be, you know, people in general are honest. That's what they suggested. Now let's get the silly question out of the way. Does this indicate that the population proportion of trusting people is higher for older group? So I'm going to have to do this in paper because your visual learners need to see it. If I'm calling this P1 and I'm calling this group P2, would you agree that's the evidence direction? Isn't P1 less than P2? You agreed? P1 is less than P2, which means later on, we're going to test that. Now, I am making an assumption here, which is always dangerous. I'm assuming that P1 is the young people and P2 is the old. And based on the numbering system, I must be correct because they called the young guys 1 and the old guys 2. Right, now the silly question. Oh, you can't see it yet. The significance level in this question is 5%. There it is. What is the significance level? 5%. Is that not going to be the easiest point in the world in a test? Now, which one of these guys, right, is the fella that I had? Well, didn't I have P1 less than P2? So it's this one. Now, this bit here, we haven't really spoken about. So here I'm going to tell you, when you're doing proportion tests, it's always the standard normal. And you're only allowed to use it if you make the assumption that the number of people is large enough. Now, large enough means n times p. In other words, is the number of people who said yes bigger than 5? If it's bigger than 5, it is. So normal distribution, big. Now, what is the value of the test statistic? That's this fella. Well, if you take P1, take away P2, we'll get that. Find the p-value. Now, it's talking about the sample statistic. That's going to come, oh, by the way, do you know the guy I call Z-score? That's him. And p-value. These are going to come from salt. So I'll have to go up here and hit salt. Let's make this a touch bigger. Okay. The one that you're going to use is inferential statistics. For everybody in 8.5, virtually everybody in 8.5, you're going to use inferential statistics. Now over here, you see how you've got a choice? Which one of that list is the one you're going to use for these questions?
The 2 sample.
Yeah. So every single one, you're going to do that. Now, it's kind of cryptic, but once you get sorted out, remember the young people were called 1. So how many successes? Well, there were 44 of those. And how many trials is just their way of saying, how many people did you ask? And I just put the wrong number here. You went asked 252. There we go. And the second one was the older group. And 73 said yes. And that was out of 271. And now it gets a little bit awkward. The hypothesized difference is always going to be 0. Because for SALT to work, you don't do the P1 less than P2. you do the P1, take away P2 is less than 0. So keep that guy as 0, and then just make this less than. So is the difference less than 0? Right. Now I'm going to come back and show you my piece of paper what that looks like. Is the difference less than 0? You see how that worked? Right. Jumping back and forth like a yo-yo today. So I'm about to hit generate, and it's going to tell me two numbers. The only two numbers I'm really interested in. The z-score and the p-value. Remember that horrible calculation? Don't need it anymore. Boom. And we have lots of guys. But the guys that matter are just, oops, z's and p. You see where they are? Z statistic, p statistic. I'm going to write down what the p-value is, 0.0468. Okay. Right, I'll copy this guy. That way I don't need to remember him. And go here. And what is the test statistic is just their way of saying what is the z-score, and it's that fella. Round your answer to 2 decimal places. Okay, that's 3 decimal places. What will that turn into if you do it to 2?
2.6.
Yeah, just a little, right. And if you want 2.60, hey, well, I'm there. There we go. And p-value 0.00468. 4 decimal places, so I guess it's going to go 47. Now I'm going to show you a little picture here. Wasn't this one a less than story, right? P1 less than P2. So you look at the picture and you look for the only one that's got a less than. Right, see the little, I wish that writing would go away. You see, I'm pointing it with my finger. You cannot see me pointing it at with my finger. But do you see the number 4 one? That's the guy, because that's a less than. Suppose it was a bigger than, it'd be that one. Suppose it was a not equal to, it would be that one. And this one you will never use because it's not going to be right in any case. So this would be a two-tailed. This would be a right-tailed when you're doing a greater than situation. And the correct answer is this one because we're doing a less than. Now, again, I'm going to have to jump back to the paperwork. Here is our p-value. Is our p-value less than 5%? Oh, less than alpha. So is 0.00468, is it less than 0.05? And the answer is yes. So that's why I'm saying yes. Now I'm going to go and figure out what does a yes mean as far as the homework is concerned. Well, when it's a yes, one of these 4 sentences is the one that we use. It's statistically significant and we reject the null hypothesis, which makes it that one. Look for the guy that says reject null and statistically significant. You see those 2 phrases are together? All the other ones are combinations that don't include those. They have at least one missing. And next, one of these is right, and interpret what that looks like. Well, we know that there is sufficient evidence, and it's that one. So look for the one that says sufficient evidence or statistically significant and rejecting the null. So do you see it rejects the null? You repeat yourself. Insufficient evidence. So what we've just shown here is what we were trying to prove. That older people think, more than young anyway, that people are honest. I'm going to unmute here. I seem to be getting some weird feedback. Okay. So most of this is going to be done using salt, at least the number crunching. I guess I could do 7. It's as good a question as any. Based on this information from a previous study, 36 people out of 102 adult Americans who did not attend college believe in aliens, right? Spacemen. However, out of a random sample of 102 who had been to college, 46 believe that there's aliens. Does this indicate that the proportion of people who attended college and who believe in extraterrestrials is higher than those who did? Right, well, if you look at those numbers, isn't 46 out of 102 bigger than 36 out of 102, right? So we need to put that together. So it's going to be a significance level of 0.01. And we're trying to say, look, those people are less than those people. So P1 is less than P2, makes it that one. This one is always that answer. Now it's time to use salt. So I better take track of the numbers then. We got 36 out of 102, and the other one is 46 out of 102. Right. Two sample. Those who hadn't been to college, 36 out of 102 believe in aliens. Of group 2 is those who have been to college, and 46 of them out of 102. Always 0. Now we're wanting P1 to be less than P2, so we want this to be a less than story. Generate the results. And the Z statistic is this number. And the p-value is roughly 0.08. So I'm rounding them off just to make my life easier. Now this was a less than story. That makes it a left-tailed test. So you look at the pictures, and one of those 4 pictures is a left-tailed test. 1, 2, 3, or 4. There you go, shaded on the left. Here you go. Is this fella, the p-value, is he less than that fella? No. So there's a no story. And what does the no's look like? Well, every no has the same 2 answers. You fail to reject the null hypothesis, and it's not statistically significant. So it's this one. Fail to reject, not statistically significant. Same basic sentence, again, just phrased a little bit differently. Fail to reject, insufficient evidence. Fail to reject, insufficient evidence. Are we good? I think we need a joke. Holly, do we need a joke? Ethan, do we need a joke?
Yes, definitely.
Does someone have a joke for me? Because I have one to tell you, but I just like to hear other people's jokes too. You ready? Anybody got a joke before I tell you mine? Right. Have you noticed that Scottish jokes are really cruel? So I'm giving you a health warning on this joke. It's a really sad story and it's cruel. You ready? So this couple in Scotland were wanting a baby and they tried and tried, but it just wasn't working. And then they got really lucky and they got a baby. But only the head was born. That's all it was, just a head. But it was intelligent and they loved it and they brought it up. And 18 years go by and the dad says, well, you're 18 now, you can go to the pub and drink beer with me. So he picks up his son and he goes to the bar and he goes to the local bar and he goes over to the bar and he puts his son down, puts the head right now. And he says to the barman, give my son a pint of beer. The barman looks at him and says, how's that? How am I going to do that? He says, look, he knows how to drink. Get him a pint of beer, stick a straw in it, put the straw in his mouth. He can drink. Barman says, well, okay then. So he does it, puts the pint down, and the head drinks the pint of beer. And then a miracle happened. His torso grew back. And the head says to the barman, says, look, it's a miracle. My torso has grown. Get me another pint. And he drinks it and his arms grow back. And he goes, this is great. Get me one more. And the whole body, everything grew back. And he's dead excited. And he turns around to his dad and says, look, it's a miracle. Look what the beer has done. My entire body has grown back. He says, I'm going to go home and get some clothes now and I'll be back in 5 minutes. And he goes to the door and he opens and he crosses the road and a bus kills him, stone dead. Told you it was a sad story. But there is a moral to this story. And do you know what the moral is?
He should have stopped when he was ahead.
Correct. Have I told you that one before?
My
Yes.
dad's told me that one.
Okay. Oh, we have got some good reactions here. Are the ones that are crying because it's sad or crying because it's that funny that they're crying with laughter?
No,
they were
it's funny.
It's funny. So you're crying with laughter. That's good. Okay, we need another joke. I don't know why I need another joke, but we do. I find what we're doing right now, especially when I do software, that it's kind of dry, isn't it? You just plug numbers in, you write them down, and then the last two conclusions are pretty much standard every time. Okay, so what one shall I tell you? How do you stop a Polish tank? Don't know? Shoot the people pushing it. Okay. Did you hear about the Polish army and the Russian army were, oh, somebody liked that one. Did you hear about the Polish army and the Russian army were having a big battle? And the Polish army ran out of ammunition. And so they look around and they find sticks of dynamite. And so they handed them out and the Polish army started throwing the sticks of dynamite at the Russians. And do you know what the Russians did? They lit them and threw them back. I don't know what that face means. Bethany and Erica, what is the face that looks like they've got their mouth open? What does that mean?
Shocked.
Is that a good thing or a bad thing? Okay.
I have one.
Okay, you ready for one last joke? I promise this will be the last one, then we'll go back to doing our stuff. You ready?
How do you make A French
Oh.
fry laugh.
I don't know how.
You tickle its potatoes.
Oh, oh, that's funny. That is so bad. It is funny. Oh. Okay, Scotsman, Englishman, and a Polish guy were fighting in a unit, and they get separated from the rest of their troops, and they had to hide because the Germans would try to find them. So they go into a forest, and the Germans are close behind. So the English guy says, "Look, climb a tree and hide. The Germans are pretty dumb. If you hide up a tree, they'll never see you." It says, "Anyway, just watch what I do and you'll be fine." So the Englishman climbs up a tree, the Scotsman a little bit further climbs up one, and a little bit further along, the Polish guy climbs up the tree and they wait. And the Germans are searching through the forest looking for them, and they get really close to where the American is, and he starts getting worried. So the Englishman, I should say, gets really close to where the Englishman is, and he gets really worried. And the Englishman thinks for a minute, and he goes, "Tweet, tweet, tweet, tweet." And the German said, "Oh, there's probably a bird up there. We'll pay no attention." And then they just move on. So the Scots guy and the Polish guy are watching this, and they think that's a good idea if they get too close. So of course they get too close to the Scots guy. And when they get really, really almost under his tree, he goes, "Squeak, squeak, squeak." And the Germans say, "Oh, there's probably a squirrel up that tree. We won't bother looking there, just keep moving." So of course they get to the tree the Polish guy is hiding under, and they get really, really close, and the Polish guy's getting a bit worried. And so when they're almost under his tree, he goes, "Moo." So anyway, they get caught. It's not over, this joke. They get caught, as you could expect, and they get taken to a jail, and the Germans are going to shoot them by firing squad the next morning. And the English guy says, "Look, the Germans are really, really dumb. If you just do what I do, you'll be able to escape." And the other said, "Well, what do you mean?" He says, "Look, it's easier if you just watch what I do and you'll be able to escape." So anyway, the Germans go and they take out the first guy, the Englishman, and they put him against a big wall. And they're about to raise his rifles. But just as the Germans are raising their rifles, the English guy goes, "Earthquake, earthquake, there's an earthquake." And they're all looking around and wondering what's going on. And during the commotion, he jumps over the wall and he escapes. Scottish guy says, "Oh, I can do that." Polish guy says, "Yeah, that's easy, I can do that." So they drag out the Scots guy once things have settled down, and they're about to put him against the wall, right? And they're raising the rifles, and the Scots guy goes, "Flood, flood, there's a flood, there's a flood." And the Germans are looking around, where's the water, where's the flood? And during the commotion, jumps over the wall, escapes. So they bring out the Polish guy, and they put him against the wall, and they're about to raise the rifles. And the Polish guy goes, "Fire, fire."
I've heard something similar to that before.
You've heard that before? Oh, okay.
Yeah, but it was like a blonde, brunette, and a redhead, and of course the blonde was the one that.
Oh, we do not do. I do not do sexist jokes. I just pick on Polish people instead. It's much safer. Which is not really true. Do you know back home all those jokes were Irish jokes? We pick on the Irish. The Irish, of course, do the same kind of jokes, but they pick on the English. Right, so everybody picks on somebody, so it kind of averages out. Okay, I think it's time for us to look at another. Yeah, we've got time, I think, for about 2 of these questions, and hopefully we're getting kind of used to them. So this should be question 8. A random sample of 288 voters registered in California showed that 142 voted in the last general election. Okay, so N1 is 142 out of 288. Gotcha. And in Colorado, right, so first one is California. In Colorado, out of 223 registered voters, 127 of those voted. So I'm just going to do a quick turn them into percentages. So in California, it looks like about 49% voted. In Colorado, it was pretty close to 57%. So does this data indicate that the population voter turnout in Colorado is higher than California? Well, guess what? Isn't that P1 takeaway P2 is less than 0? They have no imagination here. Never mind, we will use it. 0.05. Is P1 less than P2? Sufficiently large. And now I'm ready for solve. Actually, we'll do 3 questions. I want to do one more before we finish of my own. So there's a 2 sample. And California comes first. Hope you can't see it, sorry. Let me show you. This is salt, right? So California was 142 out of 288 voters. In the second group, it was 127, and that was out of 223. And we're trying to prove that the first lot is less than the second, even though it was phrased a little bit weird. That's essentially what we're trying to prove. And we generate the results. This guy here is your Z statistic, and 0.04 is the other one. So there's my Z statistic. If you round it off to 2 decimal places, looks like that. And the p-value we got was 0. Darn it, what was the p-value? Let me figure it out. And the p-value was 0.04. Oh, to 4 decimal places, okay. 0.0430. Right, is this p-value less than that? And the answer is yes. So it's that guy. You're looking for reject and statistically significant. So it's that one. You're looking for reject and statistically thingy bob. And sufficient evidence, and it's that one. Don't a lot of these questions kind of end the same way? The same couple of questions. Right, have I got time for one more? One more p-value? Any more p-values? No, these are all going to be sample mean stories, so don't really want them. Oh, excuse me. That's it. Okay, so the last question I'm going to do, I thought there would be one more, but almost cancelled you out there. Right, while I get ready, will you all say hi for attendance?
Professor,
Yes.
did you already do the extra credit for the Monday high that you forgot to say?
You see that question again?
For the Monday's check-in high? You forgot to mention
Oh,
it.
thank you. Okay, everybody. I forgot to take attendance on Monday. So if you were here on Monday, you better not say hi twice. That would just confuse me. If you were here on Monday, can you say what? Say yes. So if you were here on Monday, just type in yes and you'll get credit for that Monday as well. So if you're here on Monday, say yes. Almost ready. So the last question I'm going to do today is going to be one that I'll make up. And I want to do one that is greater than, because we seem to be picking less than no matter what question I chose. And I'd like to do a greater than. So that's kind of where I am right now. So I'm going to make up a pretend story and see what we can do with it. Okay. Okay, we're going to have two groups, and we're going to have Scottish people. Oops. I'm going to call them group 1, and we're going to have the French, that way I can pick on them in my story. And we went and asked both of these groups the same question, and the question that we asked them was, let's see, have you ever been in a fight? And they asked 2,000 Scottish males, have you ever been in a fist fight? And 150 of them, no, 1,500 of them, that's better, said yes. So 75% of them had been in a fight. And they asked 500 Frenchmen. And out of the 500 Frenchmen, 250 of them, oh, let's make it a little bit more generous, 300. So out of the French, 300 of them, which is 60%. And a significance level of 1%, which is a very high hurdle to go over, is there enough evidence to prove that Scottish people have been in fights more than the French people have? Right. Now, superficially, it's pretty obvious that it's some more, right? Since I don't have the option of picking buttons, can you imagine that you would have a story that looked like this, and your choice would be that, great. Is P1 bigger than P2? Right, so that's a bigger than story. Then you would go and you'd go over to salt, and salt would give us the ability to get all the number crunching that you wanted to do. So I'll make sure it's a 2-sample proportion. And the Scottish guys then were 1,500 out of 2,000. Now, I deliberately chose huge sample sizes because I want to show you what this does. Oops. When you have extreme p-values. Now, in this case, that's 0, and we want to prove that the first guy is greater than the second. So think of this as saying first guy greater than second. Imagine first guy here, second guy here. Right. Now, when we generate the results, the Z statistic is 6.81, and the p-value is this weird thing. What do you think that weird thing is? What are they trying to tell you? about the p-value.
Then it's just tiny.
Yeah, it's so small, you just call it 0. It's a bit like somebody saying, just call it 0. So when I come to do my last piece of the puzzle, it would look something like this. Let's test to see whether or not we've got a good result. Well, is my p-value less than my alpha? Yep. So haven't I proved statistically that there is significant evidence that Scottish people get into fights more often than French people? That's kind of what it was saying in English. So if you ever hear a phrase that says statistically significant, right, that particular wording, they have done a hypothesis test on it. And that's why they can say that it's statistically significant that somebody won Colorado or whatever it might be. Before I go, it's just a very quick piece of information. It's been brought to my attention that some of you might be communicating with me the wrong way and you're getting the feeling that I'm ignoring you. Do you know in WebAssign there's a thing that says something like ask your teacher or something? I don't use that. If you go in there, I never see it. It doesn't automatically shoot me an email, so I never hear of it. So if you ever have to communicate with me, you must use my email address or do Canvas. Canvas is good because Canvas actually is linked to my email address, and so it will send it. I don't know what WebAssign is linked to, but whether it's linked to, the only way I can even tell if there's a message is I have to go into WebAssign, then I have to go into our class, and then I have to go into a subgroup menu where I look for messages, and I just don't do that. So if some of you thought that I was just ignoring you, I am not. If you send me an email to my email address, I will look at it and I will answer it. But if you've been frantically sending me stuff anywhere else, that's why, right? So I hope that covers that issue. I think we're good to go. I'm going to hang about for 5-10 minutes, whatever.